Hello everyone, in this video we're gonna learn about the logarithmic functions. Alright, so in the previous videos we already learned the inverse function of the exponential function, which is the logarithmic function. Alright, so today we're gonna dive into the logarithmic function and behavior, concavity, and transformation. Suppose I have the function y equals 2 to the s. Alright, so this is exponential function. Alright, we have the general form. The exponential function is going to be y equals a times b to the s, right? So in this situation, a equals 1, b equals 2, right? We have two different cases of exponential function. The first case, b greater than 1. The second case, b greater than 0 and less than 1. So in this situation, b equals 2, which is greater than 1. So we're going to explore the first case, b greater than 1, right? How do we find the logarithmic function? We know that exponential function is the inverse of logarithmic function, and logarithmic function is the inverse of exponential function, right? So if both functions are inverse, they will reflect each other over the line y equals s, right? So I'm going to draw like y equals s. It's going to be something like this. Now the logarithmic function will be the reflection of the exponential function over the line y equals s. Alright, so you look at this one, the y-intercept right here, 0, 1, becomes the s-intercept right here, 1, 0, right? You're going to pick another point. This is 1, 2, and this becomes 2, 1 right here, right? This one, 2, 4, right? And this becomes 4, 2. So this 4 and 2 right here. Alright, and then you just connect this point. Now, in order to find the equation of this logarithmic function, we just take the inverse of this one. Alright, so how do we do that? Right, so we just swap s and y. It's going to be s equals 2 to the y, right? And then we look at this one right here. We see the base 2. So we're going to take log base 2 both sides, right? So this guy's same thing as log base 2 of s log base 2 right here, right? So I just fill in the blank right here. This is s and this is 2 to the y. All right, now this one I just bring y to the front, right? So it's gonna be log base 2 of s equals y times log base 2 of 2, but log base 2 of 2 is equal 1, right? So I have y equals log base 2 of s, and y, which means f inverse of s equals log base 2 of s. So the logarithmic function has the equation log base 2 of s, and this guy y equals 2 to the s, right? Okay, so now we're gonna explore the end behavior and characteristic of these two functions, right? Now first, all right, now we need to find the s-intercept. So s-intercept is going to be none, right? Because the exponential function right here never touch the x-axis, right? The s-intercept for the logarithmic function right here is going to be 1, 0, right? 1, 0. Now the y-intercept for this one is going to be 0, 1. And the y-intercept right here, none, right? Right, asymptote of this one should be the s-axis of y equal to 0. The asymptote for this logarithmic function should be y-axis, right? S equal to 0, right? The function right here is you just sketch the tangent line. and you use the Christmas tree trick. So I have the Christmas tree right here. Now if the lines go in this way, the slope is positive. If the slope is positive, the function is increasing. The lines go in this way, the slope is negative, and the function is decreasing. Alright. If you see the horizontal line, the slope is 0. If you see the vertical lines, the slope is undefined. Right? Now, when you draw a tangent line of this exponential function, it's going this way, which means right here, the slope is positive. Right? So because the slope is positive, the function is increasing. Now, you draw another tangent line. I draw this one right here. Alright, so look at the left hand side right here. If the line goes this way, and when the line is steeper, the slope is bigger. Now look at the right hand side. If the line goes this way, if the line is steeper, the slope is smaller. Now back to this question right here. So you see that this line and this line right here, right? From bottom to top, the line getting steeper, right? So because the line is steeper, the slope is bigger, right? Which means the rate of change is increasing. For example, the slope of this one equals 3, and the slope of this one is equal 5, right? So you see that to get 5 from 3, it's going to be increasing by 2, right? So the function is increasing at an increasing rate. Alright, now go to the right hand side right here. It's going to be the logarithmic function right here. So you're going to draw a tangent line. So I draw a tangent line. And I still see that the lines go in this way right here. And then the slope is positive. So because the slope is positive, the function is increasing. Alright, in order to know if the function is increasing at an increasing rate or decreasing rate, I need to draw another tangent line. So I draw another tangent line right here. Alright, so I'm going to compare the slope of this guy and the slope of this guy. So I use this one right here, right? The line is steeper, the slope is bigger, right? The slope of this line right here is bigger than the slope of this guy right here, right? So for example, this is 5 and this is 3, right? So you see that to get 3 from 5, does that mean this could be decreasing, right? So the function is increasing at a decreasing rate, because the slope of the tangent line getting smaller and smaller, right? Now, concave. Now, if you see the bow like this, if I cut this one in half, and I only see half of this one, half of this one. So if you see 3 cases right here, and then the function is concave up, right? So you look at this one right here, the exponential function right here is similar to this one right here. So the function is concave up. Now if you see the bow upside down like this, or you cut this one in half and you only see half like this or half like this, alright? The function is concave down, and you look at this one, it's going to be on the left hand side right here. So the function is concave down. Alright, the domain. Domain of this exponential function is going to be from left to right. And you see that the function keeps going up and right, right? Up and right. So the domain should be negative infinity to positive infinity. Or you just say all real numbers, right? The domain of this one, you see that the asymptote of the logarithmic function is x equal to 0 on the y-axis, right? So the function starts from 0 all the way to the right, right? And the graph never crosses the y-axis. So the domain should be 0 to infinity. And you don't take 0. because s equal to 0 is the vertical asymptote, right? Now the range, which means you look at the y-axis, right? And you see that the function is always above this s-axis, right? And never touches the s-axis. So the range should be from 0 all the way to infinity, right? So you have infinity right here, negative infinity right here, positive infinity right here, and negative infinity right here. All right, so the range should be 0 to positive infinity. Now the range of this one is going to be negative infinity to positive infinity because the graph keeps going up, right, and going down, right? So the range should be negative infinity, positive infinity, right? And you know that because the exponential function and logarithmic function, they are inverse, so the domain of this function will be the range of the other function, right? You just grab it. The limit of the exponential function f of s when s approaches negative infinity, right? This is called left limit. Alright, so when s approaches negative infinity right here, the function approaches 0. It never touches the s-axis, right? So this guy should be 0 when s approaches negative infinity. Now when s approaches positive infinity, right? S go to the right and the function keeps going up forever, right? So this should be right limit. Alright, so the function of f of s when s approaches positive infinity is positive infinity. Now take a look at the logarithmic function right here. So we need to find the left limit and the right limit. So left limit right here and right limit right here. Now left limit, the limit of the function f of s when s approaches 0 plus. So keep that in mind. 0 plus, which means 0 from the right. So when s approaches 0 plus, the function approaches negative infinity, right? 0 plus, so it could be somewhere right here. So you see that the function approaches negative infinity because it keeps going down. So this guy negative infinity. Now the right limit. Limit of the function f of s when s approaches positive infinity. The function approaches positive infinity because it keeps going up, right? So this guy positive infinity. Now let's move on to the second case of exponential function. Now in this situation, I'm going to let y equals 1/2 to the s. So in this situation, b greater than 0, less than 1. And this is a decay function, right? Now I need to get the inverse of this exponential function. So it should be logarithmic function. So I need to get the line y equal s, and both exponential functions and logarithmic functions reflect over the line y equal s. Alright, so this is the logarithmic function. Now, in order to find the logarithmic function, I'm gonna rewrite the exponential function y equals 1/2 to the s, right? So I just grab x and y. So it turns out to be s equals 1/2 to the y, right? I look at the base right here, it's gonna be 1/2. So I take log base 1/2 both sides, right? So I have log base 1/2, and this is log base 1/2, right? So I put s right here, I copy everything down. Alright, so this one I just print y to the front, so it's gonna be log base 1/2 of s equals y log base 1/2 of 1/2. Alright, so I know that this guy equals 1, right? So finally we have y equals log base 1/2 of s, and let's just change this one into inverse of x equals log base 1/2 of x, right? So the function right here, log base 1/2 of x, right? All right. Now the exponential function, the x-intercept is none, right? The x-intercept for the logarithmic function is going to be 1, 0. The y-intercept for the exponential function is going to be 0, 1. And then this guy's none. The asymptote, this guy exponential function has the x-axis. So x-axis as an asymptote of y equal to 0. Alright. The logarithmic function, the asymptote is the y-axis of x equal to 0. Now, look at this one and use the Christmas tree trick, right? I'm going to draw tangent line. So I draw a tangent line like this. And let's see that the lines go in this way. So the slope is negative. The slope is negative, the function is decreasing. Right? So decreasing. Now, I draw another tangent line to see if the function is decreasing at an increasing rate or decreasing rate, right? So I draw the next tangent line right here. Now I compare the slope of this guy and this guy. I see that the line less steep, right? The line less steep, the slope bigger. You look at this one, this guy and this guy right here. This guy right here is steeper than this guy. So the slope of this guy is smaller, right? For example, this guy's slope is -5, right? Because it's going this way. The line steeper, the slope is smaller. And this guy is -3, right? So from -5 to -3, it's going to be increasing, right? So the function is decreasing at an increasing rate. Alright? Now, look at this guy right here. So I draw the tangent line right here, and I see that the lines go in this way, which means the slope is negative. The slope is negative, the function is decreasing, right? Now next one, I draw the second tangent lines of this graph right here, and I compare the slope of two tangent lines right here. I see that the tangent lines right here is steeper than this one. So if the tangent line is steeper, the slope is smaller, right? So this guy right here, for example, this guy right here, -6, and this guy is -2. You see that? And then, all right, so you see that from -6 to -2, this is going to be increasing. So the function is decreasing at an increasing rate. All right, look at the exponential function right here. We see that the function is concave up because it has this guy, right? So this is concave up. And the logarithmic function is also concave up. Now the domain, right? This guy keeps going further to the left. This guy keeps going further to the right. So the domain right here should be -infinity to +infinity. The domain for this guy is right, is from 0, right? Because the function never crossed the y-axis. So it could be from 0 to +infinity, right? Now the range right here, look at the exponential function right here, is above the x-axis, so the range should be from 0 to infinity. And the range for the logarithmic function right here is going to be -infinity to +infinity, right? Nope, it keeps going down and this guy keeps going up. Now the left limit and the right limit. So left limit, look at the exponential function right here, limit of f of x when s approaches -infinity. is positive infinity because the function is going up forever, right? This guy positive, this guy negative infinity, this guy negative infinity, and this guy positive infinity. Now, the limit of the function ever when s approaches positive infinity, right? And then the function approaches 0, right? So it's 0 right here. Now, the left limit and the right limit of the logarithmic function. So the left limit of the function f of s when s approaches 0 plus the function approaches positive infinity, right? 0 plus right here, the function is going up forever. Now, the right limit, the limit of the function f of s when s approaches positive infinity, the function approaches negative infinity because it keeps going down forever, right? When s approaches positive infinity, right? Alright, so next we're gonna learn how to sketch a logarithmic function. How do we know the function is going up, down, left, right? So we know that if I just write ln, which means the log base e, right? But if I just write log like this, which means log base 10, right? Now let's talk about log s, right? So log s, which means log base 10 of s, right? Alright, so let's explore 4 different cases of the graph of the logarithmic function. So the first one, this is the base case. I have log base 10 of s, so I just write log s right here. So the base case is going to be like this. Now let's recall the transformation of the function, right? It's going to be a times f of b of s minus h plus k, right? If you multiply the input by -1, the function reflects over the y-axis, right? So this guy right here, it turns out to be like this, right? Now, the third case, if you multiply the output by a -1, alright, so the function reflects over the x-axis, alright? So original function right here, when it's reflect over the x-axis, it could be something like this. Alright, and the last case, if you multiply the input and output by a negative number, like this, and then the function reflect over the x-axis and the y-axis. Alright, so based on the transformation rule, right, we need to do b h a k, right? So we need to do the horizontal dilation first, right? So we need to reflect the original function right here over the y-axis first, right? Because you multiply the input by -1. So I reflect over the y-axis. So it's gonna be something like this. Alright, so from this one, I reflect over the x-axis because I have the negative side right here. Now we need to do b first and then we do a later, right? A, which means vertical dilation, right? So -1 right here, and then I reflect over the x-axis. So it could be something like this. Alright, so the final answer should be this guy, the rest one. Alright, now the trick for you to memorize is you look at the side right here. Now you see that you don't see the negative side, which means this is positive and this is positive. Positive in front of the whole thing, which means y value. Positive in front of s, which means positive s, right? Positive s, so go to the right here, this is positive s. Go to the left, this is negative s. Go up, positive y. go down is negative y, right? So this go to the right, so s positive, go up, this is positive y, right? Right here, right? Now this one right here, you see that positive y and negative s. So go over here, negative s, and go up positive y, right? Now look at this one, negative y and positive s, right? So this is positive s and negative y, right? Because the graph keeps going down. Now this one, negative y and negative s, right? So go to the left, negative s, and go down, negative y. So the function go to the left and go down, right? Now let's move on to the next example. So given the function f of s equals log base 5 of s, now describe the transformation of the function f of s to get the function g of s equals 3 log base 5 of s plus 2 minus 4, right? So we look at the transformation formula right here. Now we need to do the dilation first. So dilation right here, we have no horizontal dilation, right? Now we look at this one, this is the plus side, the formula is subtraction side, right? So whenever we see the plus side right here, think opposite. So first, right, the function f of s is moved to the left 2 units, right? Now next one, we talk about the vertical dilation, which means a right here. So it's going to be vertical dilation by a factor of 3. And the last one, we talk about negative 4 right here, which means k right here. Vertical translation down 4 units. Alright, so how do we find the vertical asymptote of this one? You just let this guy equal to 0, right? So you have s plus 2 equal to 0. You solve for s, so s equal to negative 2. So your vertical asymptote is s equals negative 2. Now to graph this one, you know that original function log base 5 of s, it could be something like this, right? And then the new function right here is going to be vertical dilation, translation left 2 units, right? So you have the vertical asymptote right here 0, right? So you move to the left 2 units. So you have new vertical asymptote, it's going to be right here. Alright. And then the function is moving down 4 units and vertical dilation by a factor of 3, right? So it's going to be something like this. Alright, so you need to find a new domain. So the domain is going to be from negative 2 to infinity, right? And the range is going to be all real numbers, right? So it's going to be negative infinity to positive infinity. Alright, the function is concave down. Now, the left limit of the function f of s when s approaches negative 2 plus, right? Negative 2 from the right, right? So negative 2 plus is going to be negative infinity, right? Because the graph keeps going down. Now limit of the function f of s when s approaches positive infinity. The function approaches positive infinity, right? Because it keeps going up forever. Or you can use the trick I showed you in the previous example, right? You look at this one, this is plus sign, and this guy is plus sign, right? When s approaches positive infinity, the function approaches positive infinity, right? To the right and up. Alright, so to do this one, we just rewrite this one a little bit, so it's gonna be 3 log base 5. Right, so we just rewrite this one in this form right here. So I just factor negative 1 out, so I have negative of s minus 3 plus 1, right? The first thing I need to do is to find the vertical asymptote. So vertical asymptote is going to be, I just let this one equal to 0 right here. So I have 3 minus s equal to 0. So I have s equals to 3. Alright, so the first thing I need to do is look at the trick right here. I need to do horizontal dilation. So we have no horizontal dilation, alright, because the coefficient is negative 1 right here. But we have the vertical reflection, right? So the function f of s reflect over the vertical asymptote, right? It's not y-axis anymore, right? This should be vertical asymptote. Now next one, we talk about the h right here, which means horizontal translation. So obviously the function move to the right 3 units, right? Now next one, we talk about the vertical dilation right here. So vertical dilation by a factor of 3. And the last one, we talk about k right here. K is equals 1, right? So this is vertical shift by 1. Alright, so now we're gonna graph this one. So we have the original function is gonna be like this. The vertical asymptote is gonna be 3. So this is 1, 2, and 3. 3 right here. Alright, so we draw a vertical asymptote. Alright, now we just get the new one. So the new one should be something like this. Alright, now we need to find domain and range of this one. Domain is going to be negative infinity to 3 right here, right? Range, it should be negative infinity to positive infinity, right? Because the graph keeps going down and going up right here. Now, the function is concave down, right? And we have a vertical asymptote as equal 3. Okay, now the end behavior. So the left limit of the function g of s when s approaches negative infinity, right? The function approaches positive infinity. Now limit of the function g of s when s approaches 3 minus, right here. This is the right limit. So it's going to be negative infinity because the function keeps going down, right? Now let's move on to the last example. So for example, I have the function g of s is negative log base 5 of s minus 3 minus 2, right? So the first thing I need to do is to find the vertical asymptote. So vertical asymptote, I let this one equal to 0. So s minus 3 equal to 0 and s equal to 3, right? So if I graph it, original function is going to be something like this, right? And then this guy's 1, 2, and 3 right here. So vertical asymptote is going to be right here, s equal to 3. Alright, so now I look at this one. I need to do horizontal dilation first, b. So there is no horizontal dilation. I skip this one. Next one, horizontal translation, right? So actually the function f of s shifts 3 units to the right, right? Now next one, we're gonna talk about the vertical dilation, right? So there's no vertical dilation, but there is reflection right here, negative 1, right? So it's gonna be negative 1 in front of the output, which means reflect over the s-axis, right? And the last one, this one k equals negative 2. So this is the function average shifts down 2 units right. Alright, so if you grab it, it's gonna be something like this. Alright, so for 3 different cases right here, you can use that most to check your answer. And it's good time to start. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand